Bismillahirrahmanirrahim. Now try to continue 11.3. Actually, we did good number of examples, especially for the old exams. As I said, usually it goes around what? Solving it, going from the differential equation to the recurrence relation, or classification the singular point, initial equation, or from the recurrence relation to the solution. Usually it goes around that. So now let me do more examples about solving differential equation using series solution. Yeah, where I have, if you notice, I have two R's. So, okay, this is what we will get. Now let me try to find the answer. And notice that x equals 0, very clear, is a regular singular point. So it will be my solution. Y equal summation n equals 0 to infinity Cn x to the power n plus r. I have this r. So y prime, don't forget the same starting point, n equals 0. But now derivative of this, x to the power n plus r minus 1, y double prime, the same thing. But now I need n plus r minus 1, x to the power n plus r. Don't forget minus 2. Okay, now the equation, I have 2xy double prime, 1 plus x y prime plus y. Yeah, I need to multiply 2x by y double prime. So I have what? Summation n equals 0 to infinity Cn n plus r. Don't forget the 2. Sorry. Let me write the 2 first. 2Cn n plus r n plus r minus 1 x to the power n plus 2 minus 1. Because I have minus 2 times x. I mean x to the power n plus r minus 2 times x to the power 1. So I have x to the power r n plus r minus 1. Sorry. Yeah. I add 1 to this. Okay. Now plus y double prime, which is plus summation n equals to infinity Cn n plus r x to the power n plus r minus 1. I think we did this to x y prime. Yeah, but this is plus y, this is minus y. No, it's the same. No need to do it again. Yeah, or not waste time. Yeah, it's the same one. Oh, but this is I get only the recurrence relation. This one I get only the recurrence relation. Now let me do it. Let me do it again. No problem. Okay. Now plus x times y prime, so that will be plus summation n equals 0 to infinity Cn n plus r x to the power n plus r minus 1 plus 1, that will be x to the power n plus r plus summation n equals 0 to infinity Cn x to the power n. That should equal to 0. Okay, now notice here these two, because that I remember I did it, that this is 0, the power is the same, so I can combine them in 1. That will save my time. So I have 2Cn, yeah. And notice I can take Cn as n plus r, also common factor. What's the remaining? 2 n plus r minus 1. Okay. 2 n plus r minus 1 here. And there I have plus 1. Yeah, because I took all of this as a common factor. Times x to the power n plus r minus 1. Plus summation n equals 0 to infinity. Also, I can combine this. I have Cn common factor. I have n plus r plus 1. X to the power n plus r. Okay, now I need to simplify this. What is this? 2n plus 2r minus 2 plus 1 minus 1. I can take x to the power r common factor to save time. I can take x to the power r common factor outside. So I have what? Summation n equals 0 to infinity. I have what here? Cn n plus r times 2n plus 2r minus 1 x to the power n plus r minus 1 plus, don't forget I get rid of x to the power r, so this is n minus 1 plus summation n equals 0 to infinity. What I have here? Cn n plus r plus 1 x to the power n. This is equal to 0. Okay. Now I notice, as I said before, this is, you have the power starting from -1, here the power starting from 0. So I open the first one, the -1. That will be what? C0, n equals 0, C0, R, 2R minus 1, okay, x to the power -1, and the rest is starting from 0, from 1, n equal 1 to infinity. Cn, n plus r, 2n plus 2r minus 1, x to the power n minus 1. And this is same. I'm not doing any changes. Yeah. Now I do from here, I get what's called indicial equation. Since it's 0 is arbitrary, so I have r2r minus 1 equals 0. This is my indicial equation. So I have r equals 0 or r equal half, which is these two, r equals 0 and r equal half or equals 0. Yeah, do it the way you like. Now I will continue. This is equal to 0. So I have what? I need to do this trick where k equal n minus 1. Just to make it equal. And this is k equal n. To fix the powers, I need the same power. So I have this is xr. This I have c0 r to r minus 1 plus summation k equal n minus 1 means n equal k plus 1. So I have k starting from 0 to infinity. Then forget n is k plus 1. So I have k plus 1, k plus 1 plus r. Yeah, what we have here? N is k plus 1. So we have 2k plus 2. So we have 2k plus 2r. 2 minus 1, that will be plus 1. X to the power k plus summation. This is nothing, just we wrote it. K plus r plus 1 x to the power k. I notice now everything fixed, the starting point fixed, and the powers fixed. So that means this is خلاص, I'll get rid of it. I have x to the power -1, sorry. So this is, I get the indicial equation. Now I need this relation. So I have ck plus 1 times k plus r plus 1 times 2k plus 2r plus 1. Notice I have the same thing, so I can combine in one series. So I have this is equal to 0. So I have ck plus 1. This is cannot be 0. So I have, I can't do it in 2 steps, minus, this is equal to minus ck k plus r plus 1 over k plus r plus 1, 2k plus 2r plus 1. This is cancelled, never 0. So I have minus 1 over 2k plus 2r plus 1 times ck, where k is 0, 1, 2, and so on. Now I need to go to the solutions. So take the 2r. If r equals 0, I'm getting ck plus 1 equals what? Minus 1, r equals 0. So it is minus 1 over 2k plus 1 times ck. Yeah, by the way, here we have what? We have C0 is arbitrary, huh? C0. Okay. Now, do k equal, where k is running from 0, 1, 2, 3, and so on. I have k equals 0. I'm getting what? C1 is minus 1 over 1 C0. So it's minus C0. K equal 1. Is it? K equals 0, so I have minus 1 over 1. Yes. K equal 1, so I have minus 1 over 3 C1. And C1 is minus C0, so that will be 1 over 3 C0. Let me do one more. C3, that will be what? Minus 1 over 2 times 3, 7 times C2. And C2 is 1 over 3, so that's minus 1 over 21 C0. So it will be the solution. It will be, I can write C0, C1x plus C2x squared. Don't forget x to the power r. So summation n equals 0 to infinity. Cn x to the power n plus r. This is r1, where r1 is 0. So this is summation n equals 0 to infinity. Cn x to the power n, which is we know how to do it. This will be C0, C1x, C2x squared, C3x cubed. By the way, there you can continue, but I'm doing it only for few numbers. C1 minus C0x, C2 is 1 over 3, C0x squared, and this is minus 1 over 21, C0x cubed, blah, blah, blah. So I can write it C0, 1 minus x, 1 over 3x squared, but this is my first solution. This will be y1, y1. Okay, I didn't write it. Okay. Now for R2, which is what? Half. What will be the relation? Ck plus 1 will be R2 equal half. So it's minus 1, 2 times half. So it's minus 1 over 2k plus 2 ck. Now, if k equals 0, what I'm getting C1 will be minus 1 over 2 C0. K equal 1 C2 will be minus 1 over 2 times 4. 4 plus 2, 6. But C1, so that will be 1 over 12 C0. K equal 2. I'm getting C3, which is what? Yeah, minus 1 over 8. Yeah, 2 times 3 plus 2. C2, so that will be minus 1. 8 times 12 is what? 96. Yeah, C0. So the solution will be summation n equals 0 to infinity. Cn x to the power n plus r2. And that will be summation n equals 0 to infinity. Cn x to the power n plus half. This half I can take it, x to the power half I can take it out. I'm getting what? Oops. I'm getting C0 plus C1x. Okay. So I have x to the power half outside. I have C0. What is C1? Minus half C0x plus C0x squared, 96. Notice I can take C0 outside. So I have x to the power half times what? 1 minus half x plus 1 over 12 x squared 96 x cubed. Well, now this is my second solution. Yeah. Okay. There's another problem. Find the first three non-zero terms of this. Yeah. I have 2x squared y double prime minus 6y prime plus x squared plus 1y equals 0. About x equals 0, corresponding to what? To the smallest indicial root. Okay, he wants me to find the solution, but with the three non-zero terms, but to the smallest indicial root. Okay. Yeah, I can do it right away. Yeah, instead of I have x equals 0 is very clear, is a regular singular point. Regular singular point. So what I will do, the solution will be like this. Let me save time, just plug it into the equation. So I have 2x squared y double prime minus 6y prime. Wow, plus x squared y equals 0. Equal what? Yeah, and I squeeze it here. I'm not sure. Let me start from here. That will be summation 2 Cn n plus r minus 1 x to the power n plus r minus 2 plus, since I'm multiplying by x squared, plus 2, so this is gun minus summation Cn n plus r x to the power n plus r should be minus 1 plus 1 gun also, this is starting from 0, don't forget. Then plus x squared times y plus y. Let me start with plus y, since I can combine all of these ones in one, plus the one with the n equal 0 to infinity. 0 to infinity. This times x squared, I have Cn x to the power n plus r plus 2. That should equal to 0. Yeah. If you notice, I have, this is starting n plus r, n plus r, n plus r. So I can combine them in one. Yeah. Okay. Let us see what will happen. I have summation n equals 0 to infinity. Yeah, let me write it. Let me take Cn outside. I have 2 n plus r times n plus r minus 1 minus n plus r plus 1. All of this x to the power n plus r plus the rest summation n equals 0 to infinity Cn x to the power n plus r plus 2. These two series, okay. Now here I can I combine it? Yeah, I can combine it. How? This is no, it will not be easy one. So leave it as this. Okay. Now I can take x to the power r common factor. So I have x to the power r. What is the remaining? Just to see it, I have Cn. I have 2 n plus r n plus r minus 1 minus n minus r plus 1 x to the power n plus summation n equals 0 to infinity Cn x to the power n plus 2. Cn x to the power n plus 2. Okay. Okay, what to do now? This is, will give me what? Now, if I do the case of changing it into 2k, I have k equal n here, and here I have k equal n plus 2, so n equal k minus 2. So start from 2 in here. Let me do it, see what will happen. I have summation, I have x to the power r is equal to 0. So this implies x to the power r times what? Summation k equals 0 to infinity. Ck, we have here what? 2, keep it as is. K plus r minus 1 minus k minus r plus 1 x to the power k plus summation here k starting from 2 to infinity. Ck plus 2 x to the power k. Okay, x to the power k. Now I fix the powers. I need to fix the starting point. This is 0. So that will be x to the power r. Open the first one. I have C0. Usually I work with C0 as number 3. I have what? Yeah. At C equals 0. At k equals 0, I have what? 2r times r minus 1 minus r plus 1. Okay. Okay. And then x to the power 0 plus C1 now, 2, k equal 1. I have 1 plus r times k minus r equal 1. So this is r again. K equal 1. So this is minus r, because this is minus 1 plus 1, gone. All of this times x to the power 1, and the rest is starting from k equal 2 to infinity, where I can combine these two series, 2k plus r, k plus r minus 1, minus k minus r plus 1. All of this times ck plus ck plus 2, and all of this times x to the power k. That is equal to 0. Okay. Now I have this is equal to 0. So I have C0 is arbitrary. Yeah, I need C0 to be arbitrary. So I need this to be 0. So I have 2r squared minus 2r minus r plus 1 equals 0. I get this here roots from here. So I have what? 2r squared minus 3r plus 1, which is what? 2r. I have r minus 1 equal to 0. So I have r equal half, or r is equal to 1. So it is the smallest r is half. I get half. Now I'm working with half now. So my work is with half. Now this one is what? This one I'm getting what? C1 times r is half. 2. Now you're taking r equal half. I have C1, r is equal half, 2, 1 plus half, 2 times 3 over 2 times half minus half that is equal to 0. So for sure, I'm getting C1 equals 0. This is a number. Yeah. This will be what? 3 over 2 minus half, which is 1. So C1 equals 0. And from here, I'm getting the relation. I'm getting the reconciliation from here. So I have CK plus 2 will be, yeah, minus all of this, but R equal half. Huh? So let me take it to the next page. I have what? 2K plus R. Okay. K plus R minus 1. Okay. Minus K minus R plus 1. All of this times CK plus CK plus 2. This is equal to 0. Where K running from where to where? Where K is running from 2. K equal to 3 and so on. Am I right? Yeah. No, wait a minute. N equal K minus 2. No, this is K minus 2, sorry. This is K minus 2. This is K minus 2, not plus 2. Yeah, since N is K minus 2. This is K minus 2. Okay. So this is K minus 2. So that implies CK will be equal to what? Equal, yeah, minus CK minus 2, 2K plus R, K plus R minus 1 minus K minus R plus 1. I'm getting R equal what? Half. So let me fix this. R1 equal half. Yeah, I need to do this. Let me do it here. 2K plus half. K plus half minus 1. That will be K minus half. Minus K minus half plus 1. So it will be plus half. Okay. So fix that. That will be 2. That is what? K square minus 1 over 4 minus K plus half. Yeah, correct? And this is probably two functions. Okay, so that will be 2K square minus half minus K plus half. Yeah, this is equal this, and this is K times what? 2K minus 1. Yeah. Well, K starting from 2. Yeah. So this is minus 1 over K, 2K minus 1, C, K minus 2, where K, 2, 3, and so on. Yeah. Okay. Now let me do the calculation. Now K equal 2. We're getting what? K equal 2. I'm starting from 2, sorry. I'm getting C2 equal to what? C1 is 0. C2 will be minus 1 over 2, 3, C0, gone. K equal 3. I'm getting C3 minus 1 over 3. 2 times 3, 6, 5. C1, which is 0, gone. K equal 4. I have C4 minus 1 over 4. 2 times 4 is 8 minus 1. That will be 7 times C3 times C2. Sorry, times C2. Yeah, by the way, this is minus 1 over 6 C0. And that will be what? That will be 128 times 6 C0. 30 times 6 is 180 minus 12. That will be 1 over 168 C0. Okay, so the solution will be y equals summation n equals 0 to infinity Cn x to the power n plus r1, which is half. That will be n equals 0 to infinity Cn x to the power n plus half, where I can take x to the power half outside. That will be C0 plus C1x plus C2x squared plus C3x cubed plus C4x to the power 4, and so on. Why I stop at 4? Because I know this will give me the 3 term. I can only have the C0 at the beginning. So that will be x to the power half C0. C1 is 0, gone. This is minus 1 over 6 C0 x squared, C3 gone, plus 1 over 168 C0 x to the power 4. If I took C0 as a common factor, what is the remaining? X to the power half times what? 1 minus 1 over 6 x squared, 1 over 168 x to the power 4. So this is the solution, y1 over x. And that's what we get, exactly. So it's just a matter of calculation, you know. Just we substitute it. We did the calculation, we fixed, as usual, we get C0 as the birth rate to get the indicial roots. This is I get the indicial equation, I fix the root, and he wanted with the smallest one. Then I do the calculation. I notice that C1 equals 0 from here. So I do the calculation, I get everything. That will be nothing here. Yeah, I did it in the next page, yeah. Okay, just before I finish this this part about the examples, you notice all the cases we did when we have the indicial roots. I'm getting 2 roots where the difference between these 2 roots is not an integer. I have, like in this case, I have 0 and half. In this case, in the next one, I have what? Half and 1. So I have 3 cases actually when I solve about regular singular points. Look at the difference. Look at these 2 indicial roots. If they are not the same and the difference between them is not an integer, always I can get 2 linear independent series. I have xn plus r1, xn plus r2. Since the difference between them is not an integer, for sure these 2 series, they will not reach each other. This will give me a solution, and this will give me another solution, or these 2 solutions are not the same. I will go to case 3, then I'll go back to case 2. If R1 equal R2. So for sure, I will not write the series in the same way since they have R1. So usually they are doing it with this trick through len x, which is very complicated to find. So, but this is the format of the solution. The first one is the regular one, Cn x to the power n plus r1, since they are the same. But the second one is in this format, y1 of x ln x plus the summation, another summation, where I need now to find bn, which is a very complicated calculation. Now we'll come back to this is the reduction of order, which is not part of this course. Now let me go to the case 2. If R1 not equal to R2, but the difference between these 2 R's is a positive integer, I'm supposed to get 2 answers, like in this case, like in case 1. But there is one problem I should notice. Assume I get Cn x to the power n plus r1 and Cn x to the power n plus r2. Since the difference between these 2 r's is an integer, so there is a possibility these 2 series are the same. You know, with just changing the indices, that will make it will make these 2 series are the same. I have bn, sorry, I have another series here. So since the difference between them is a positive integer. So that means what? There is a possibility these two are the same, because when they write the format of these two cases, they are doing it in this way, where they put this capital C. And that capital C, if these two series are not the same, then I will make this C 0. I'll make this C 0, so I cancel everything. They have like case 1. However, if they are the same, then this C will make the format like in the third case. Where is the third case? Yeah, where I have the len. So that's my lead idea. That's what I want you to understand. So this will be obtained for Frobenius. One may get two series from the Frobenius, one for each. So in this case, C equals 0, as I said, or one may get only one series and obtain the other by using the reduction of order, as in the previous example. Okay. So this is what I want you to know. So mainly we are doing the calculation. We are doing this calculation, but as I said, usually there are three cases. It depends on the difference between the indicial roots, or if they are repeated or not. But usually we work out with finding the solution, either the smallest indicial root or one of the indicial root. You can find the answer. You can find at least one solution for sure through the series solution. The other solution, you need to do it with the complicated solution, complicated calculation, which is not part of this course. Okay, now what is the remaining? What do you think I will do in the next videos? I will do all the exam questions, written exam questions. Okay, this will will take some time just to show you examples about this. All the exams questions, written part. We did the multiple choice, and I think the multiple choice will be more than enough. But I will do these things to complete the file. I will stop the recording. Then we'll move to the next recording channel later. Thank you.